So hello everyone, welcome back to our channel. So previously we have done a question over stack, and for today we will be continuing some arithmetic operations and learn uh, about prefix, infix, postfix conversion. So in our college journey we have learned about prefix, postfix and infix. So basically, infix follows L and R generally, where all the elements are in the format of left node and right in a tree. So it kind of similar in our stack. And so firstly, we will be doing infix to a postfix conversion. Before that, we have to set the priority of our operators. So there are two things, operators and operands. Operators are the operators that's like divide, multiply, minus, plus. uh, these are the operators, and operands are basically the uh, they belong from capital A to small capital A to capital Z, and small a to small z, or 0 to 9 numbers. These are the operands. So a calculation, a simplification is made using some operators and operands, and uh, the simplification that have included the operator and operand combination in a normal way, like in a infix way, like L and R way. So they are called as infix, while prefix are those whose operators are in front of them and operands are on their backside. While for the postfix, we have operands on the left hand side and following up by the operator. So this is the overview. And for the priority of our operators, power operator like 2 to power 3. So power operator is the highest priority. We will set its priority as 3, and multiplication and division have the priority of 2, while plus and minus have priority of 1. And other operators like bracket or opening bracket, closing bracket, etc. So these have the priority of -1. We will set that. So for the infix of to postfix conversion, firstly we will take an I iterator, we will take a stack, and take an answer string. Currently answer string will be empty. So I will let you example where we have a plus b multiplied by bracket of c to power d minus e and bracket close. So this is a postfix infix operator. So for this we will be setting two major rules. If there is any operator comes, we will put them in the stack, and if it is a operand, so we will put them in our direct answer string, and there will be some condition over putting the elements, like if a closing bracket enters, so we will put them in our stack. But when the closing bracket enters, so the number of operators that have been inserted in our stack from opening bracket to closing bracket, all of them will be popped out. And if a less priority operator comes out of the higher priority, so suppose like there is a condition where we have a in our stack we have a higher priority operator, and now a small priority operator is coming. So we will firstly pop out the higher priority operator, and then after we will put our small priority operator. Such as in our stack, the condition is as given as we have plus operator, and then we have multiply operator. So multiply operator will come, but in we reverse the case, like in our stack we have multiplication operator available, and now new operator that will be coming will be a minus operator. So firstly we have to pop out the multiplication operator, then after we can put our minus operator in our stack. So these are some basic rule. on which we will able to write the code. So for the code of infix to postfix, we will take a string I iterator stack st and answer string, that is empty. So we will be running while I is less than n, where n is our string size. So we will check the condition. First condition we will check for if our s of I, that means the string's first element is a element from a capital A to small capital Z or small a to small z or 0 to 9. If it is any element, so we will simply insert that in our string directly and not put it in our stack. Else if there is a condition, if s of I is a closing opening bracket, so we'll put them in our stack. Else if it is a closing bracket, we will just make a loop until reaching up to our opening bracket. All the operators will be popped out one by one, and after popping out them all, we will pop out our opening bracket as well, but not include in our string. And the operators that are popping out, firstly they will be added in our string and then popped out. So that is one condition, and after this their last condition will be as if our string is empty, we will check for empty and set the priority. If the higher priority element is coming and a lower priority is available, so we will simply put them. And if for the vice versa case, if there is a higher priority element in our stack and lower priority comes, so firstly we will pop out our higher priority element, and after that we will insert our lower priority element. So that's how we will able to put all the elements, and in the last we will check if the, any element is remaining in our stack, then we will simply pop it out and add it to our string answer, and in the end we will return our answer string. So that's how we will be able to convert our infix to postfix conversion. And now coming upon from infix to prefix conversion. So prefix are those whose operators are coming firstly and then operands. So for this we will follow three steps. Firstly, the given string will be reversed, and after that we will be converting our that reversed string infix in string into a postfix, and after converting into a postfix string, we will be reversing back it into our new string. So we will reverse it back. So mainly three tasks: reverse the string, convert to postfix, and then again reverse the string and return the answer. So that's how we will be able to solve it. There will be some condition in this also. So for example, we will take simply as like postfix. We will simply put all the elements. If there is a closing bracket or and opening bracket, these all condition will be same. So coming up and directly into the code. So for the code of infix to prefix conversion, we will firstly reverse the string s and make them a new string, and again taking iterator I equal to 0, a stack and a new string, that is our answer string, which will be empty. So coming upon the loop where I is less than n and checking the condition, if I is any operand like a capital A to capital Z, small a to small z, or 0 to 9, if there is any operand available, we will simply add it in our answer string. And if else if any opening bracket is available, we will put it in our stack. And else if it is a closing bracket, for the closing bracket, again we will run a loop until our closing opening bracket will be matched in a stack. Until that we will be popping out and adding it in our string element, and the end we will be popping out the closing bracket as well, but not adding it in our new string answer. In the last condition, that's the main condition, if our s of I is a power operator. So power operator, we have set the priority 3, that's the highest priority. So for this we will be checking if our stack is empty or not, and check the priority. If we have the priority same as the power string of priority, or we have the priority of s of I, that means the current string on which we are heading, is less than or equals to the priority of our top element of the stack. Uh, so our s of I is currently power operator, and our top element of the stack should be greater than or equal to. That means it should be equal to, means two power operator cannot be simply put together. So for this we will be firstly adding it in our answer string and then popping out from our stack without pushing any further element. So it is one of the condition, and there is another condition where we will be checking if our stack is empty, or our priority should, as of I string priority, that's current element priority, should be less than, not equals to. In previous question we will be checking for less than and equals to condition. In this we are only checking if the priority is lower than the priority of our stack element, that's the top element of our stack. If this is the case, only in this case we will be adding the element in our string, and after that we will be popping out from our stack. So we will be adding the stack's top element in our string and popping out before any pushing of element. A small priority element will be pushed further. Firstly, our top priority element will be pushed, pop out, and put it in our answer string. After that, we will be pushing our small priority element, and iterator goes on. And after this, in the end, we will be checking for the loop if stack is empty or not. If it is not empty, simply add all the elements of stack in our new string in a leaf order, and after that we can we have to reverse the answer list again and then return the answer. So that's how we will be able to solve for this infix to postfix infix to prefix conversion via postfix. So that's how we will be able to solve this problem, and complexity of this reaches to big O of 3n for n by 2 for reversing, and n by 2 for again reversing, and big O of 2n for the overall reversing of elements. And we are taking space complexity of the stack, so big O of n will be the stack space complexity, and that's how we will be able to solve. For further, we will be continuing the video as postfix to infix and prefix to infix conversion in our next video. Until then, stay tuned, stay happy. Thanks.